Hi guys, I thought it might be useful to put together a video about how the Lexus LS430 air suspension works. This kind of also applies to the 460 and to the LS600H as well, which use basically the same air suspension setup. So there's a lot of misinformation, a lot of confusion out there about what the various components do and how they wear out and so on. So I'm going to go through in this video all the different components, talk about what they do, talk about where they're fitted, and then at the end I'm going to go through and talk about some of the common faults that occur on these and how you might go about fixing them. So let's get into it. So the first major component obviously is the air suspension struts themselves. So what I've got here, this is a front one, this is a rear one. The front ones are slightly shorter, but they're basically the same design. They work similar to a normal coilover setup, so you've got, instead of a spring here, you've got an airbag. The airbag actually is inside of these, it's in there. This is just a sheath over the top to keep road debris off, so that's perfectly normal to have that slit there. So you've got the airbag instead of a spring, and then you've got a conventional damper running up through the middle of it. And that is an oil-based damper system there. So we'll press this. There we are, and you can see it's gradually coming back out. The oil dampening to slow it down. So the damper side of it is exactly like a conventional setup. It's just that the spring has been replaced with a bag. Air comes in and out through here to inflate and deflate the bag. On top you've got adjustable dampening. That's provided by this little actuator, this little stepper motor that sits on the top there. There's one of those on all four corners to adjust the stiffness of the dampening. So, like I said, there's one of these for each of the four corners of the car, and as well as that, you've got a height sensor for each of the four corners of the car. So, I've set one up here in the vise, show you how this works. So, if your car is sitting at its normal ride height, it should be sitting approximately like that. So the top arm is horizontal. This arm up here is horizontal. The bolt here and here attached to the body of the vehicle, and down here this piece attaches to the lower suspension arm in the same way as this connects to the body at the top, and at the bottom of the strut it connects to the lower suspension arm. So as this gets shorter and longer, as the car is bouncing over your road, this will be moving up and down. So if we look at this, there would be considered normal height for the car. If the wheel goes up further into the wheel arch, it ends up in that position, and if the wheel gets further away from the wheel arch, so the car gets higher, then it goes downwards like that. And so the car can read this data through the wire that it's attached to and decide what to do about it. So that's one of the inputs that the car will take to decide how tall the car is. It's looking at all four corners. There's four of these sensors on the car, two for the front, two for the back. Looks at all four of those, looks at their data to determine which ones are high, which ones are low. And it also takes data from your dashboard here. So this is one of your dashboard panels, and you can see there are two buttons here that are relevant to the air suspension. There's a sport option, so you can turn it to sport or normal. That actuates this stepper motor to increase the dampening force, so that's what that button actually does. And we have a second one here for high and normal. If that's set to high, the car, instead of wanting to have the arm horizontal like this, will have it a little bit more like that. So that's another couple of inputs that the car takes. And what it does with that data is it sends it over to the electronic control module for the air suspension. That's this part here. On right-hand drive models, this lives behind the glove box inside the dashboard. So it's looking at all this data and deciding what to do. It may think, oh, I've got one corner that's too low, or it might think I've got all four are too low and I need to raise the whole thing up. For instance, if you just turned on high, it says, oh, I'm going to have to add some air to all four of the air struts to get the height that I'm after. So how does it go about this? Well, that's where the kind of air side of the system comes in, which is these two components and this. So let's have a little talk about them. So we'll start off by talking about this piece. This lives on this side of the vehicle, roughly in here in the wheel well. And this is the compressor, so along with another few components attached to it. So this is the air compressor that actually sends air into the system. I've loosened the plate up here because we're going to talk about what goes on inside that in a second. As well as that, here you've got this, which is a air dryer and filter for purifying the air before it goes into the bags. And turn that over. And here we've got two solenoids. So this is the front one and this is the rear one. And both of these have an input. In the case of the front one, this is the input, and then it has one or more outputs. So the front one, air comes in here from the compressor, comes in here, and then it can be sent out to the left and right bags on the front out of these two pipes which are cut off here. It can also, or it always rather, when air comes in here, always has a path to go out on this hard line. This hard line runs to the rear of the car, where it comes into the rear solenoid here, and this solenoid can optionally send air out of these left and right pipes here to the left and right bags on the rear. So these solenoids here are, if we look at the back here, they're electronically controlled. 3-pin plug there. Get a good look at that from the other side. And there's two solenoids here which can turn on or off to allow or block air from going in or out of these airbags. So the electronic control module over there can send signals to this to open or block the path to any of the bags. By default, these will be in the off position when no power is being sent to them. So when the car is turned off, the bags are essentially locked and no air should be able to escape from them. Okay, so let's talk about how the system would react if one of these air suspension bags was found to be too low. So the sensor data that had come into the ECM is saying to it that that corner is too low. What that would look like in practice is the wheel has been pushed up, and so the arm is somewhere up here where it needs to come back to horizontal. So the ECM will send a signal to the compressor to start running. The compressor will turn on. It will then, inside here, inside this, is a piston that runs up and down when the compressor is running. If we take this off completely, you'll see there are a number of pathways through here. Air comes in through this large pipe, which comes round to here and into the back of this body. It comes up through these filter meshes, these filter elements, and it passes over this lip here into this chamber. From here, there's a reed valve, and as the piston goes down, the reed valve will open out of the way and air will pass into the cylinder here. As it then starts to come back up again, it will push against the reed valves, which will close them. This will leave the air unable to come back into this chamber. Instead, there's a little spring-loaded, essentially valve here that goes into the chamber. So the air will come out through here into this chamber. The only place that it can go from there is through a hole here that leads up into the air dryer. So the air in here will be dried and also filtered, and it will come out of this tube. This tube is directly connected to the front solenoid coming in here. The ECM has already turned on the compressor as mentioned, and it's done all of that work and pushed the air, or started to push air into here. The ECM will also open one or more of these solenoids, whichever one has the path to the bag that it considers to be low. That will allow the air to flow out of it and to flow in to here, add more pressure into this bag and cause it to rise by pushing against the weight of the car and pushing the wheel downwards. Once the system has determined that it's now at the correct height, it will close these solenoids and it will stop the compressor from running, and that will be the system inflated correctly. Now there's a couple of times that could happen. Obviously you could have an air leak that could cause it to go too low and then the compressor will need to kick in. Another option is maybe you've pressed the high button on here and now it needs to add air to all 4 bags. Another situation that can happen is that you've put a lot of load into your car. So for instance, you've put a lot of heavy weight into the trunk, or you've had a lot of people have gone into the car. That will cause the car to sit a little bit lower, and so the car will need to raise up to compensate for that. So what about the opposite situation where the car finds itself too high? So that might happen if you had high mode engaged and then you turned it off. Or maybe there were a lot of big people in your car and they all got out. Another situation that happens is at speed, at motorway speed, cruising speed, the car actually drops itself slightly to improve aerodynamic efficiency. So you'll notice when you come on an off-ramp, off a dual carriageway, on a slip road, that you might hear the compressor kick in. That's because it's actually dropped itself while you've been driving at speed and it's now having to raise itself back up again. So anyway, let's talk about how the system will work when it needs to actually get rid of some air. So let's say that one of these bags is too high, it's got too much air in it. The system has detected that this is down here and now it wants to get it back up to the middle again. So what it's going to do is it's going to decide, okay, which connection, which solenoid is the one that controls that bag. Let's say it's that one. So it's going to open that solenoid, which will allow a path back through from the rear there, back through the front solenoid block, out through there, allows it to come back down the path here, through the dryer the other way, and back into this block. Now it's not going to turn on the compressor because the compressor can't be run in reverse. So the air is in this section here, it's coming back in, it's in this little piece of the block here. And if we look really carefully, there's a very small hole there, and there's a corresponding small hole. I don't know if you can even see this. Try and get a light on it. There we go. There's a corresponding small hole on the other side. So one over there and one over there. These two holes normally are blocked from each other, so there's no path for air to come through. But when the system knows that it needs to drop the level, it actuates this other solenoid that's on the back. And this solenoid is a single solenoid that allows air to pass between those chambers when it's opened. And that allows the air then to flow back through here, back through this filter, and back out of the line that it originally came in. So it's purging the system back completely in reverse, and the air is just allowed to escape out to atmosphere basically in this sort of engine bay wheel well area. So that's really all it does there. It just leaves that valve open, the exhaust solenoid as it's called, and it opens the appropriate distribution solenoid here to allow a free path for the air to just escape to atmosphere. And that's all it does. There's a common misconception that there are exhaust solenoids for the front and rear of the Lexus LS430. That is not the case. There's front and rear distribution solenoids, but there's only one exhaust solenoid, and it's right at the front. So I think that just about covers how the system works. So let's go through these components one by one and talk about any failure points that they may have and how to diagnose those failures. Alright, failure points. Let's start with the easy stuff. These switches don't really tend to fail, they tend to be pretty reliable. ECM, again, pretty reliable, there's not much to it. These little stepper motors, pretty reliable, not a lot to worry about. These, the struts themselves, definitely, these are getting on now, they're 20 plus years old on the 430s. They've done a lot of miles, failures are going to be happening on these. So, a couple of ways they can fail. The air bags themselves can start to leak. It's not as big of a problem with people having blowouts or problems with them as it is on, say, some Mercedes models, but failures are possible on those. A common failure you'll see on these is they'll start to leak oil down these shafts. That's obviously damper fluid escaping from it. That will present itself as a kind of rough, harsh ride on that corner, maybe some knocking noises. If that happens, it's time for a new strut. There's no real way around it, either new or second-hand. So yeah, they're definitely points of failures, those. Another common point of failure is height sensors. Obviously, these are sitting in the wheel wells of all four wheels. They're kind of prone to getting covered in salts and dirt and, you know, just getting battered. So water ingress occasionally happens on these. That will then start to get erratic readings or no reading at all from these, and that can obviously cause a problem with erratic behavior on one corner of your car, you know, going high or low with no rhyme or reason to it. If that's happening, you could suspect a failure maybe of the sensor. Another problem you'll see on these sensors on the rears is where they attach at the bottom. There's a little loop that they attach to the bottom arm of the suspension. That loop can actually rust and snap off. When it does snap off, you'll see that this arm just sort of hangs down and wobbles about as you're going down the road. If that happens, the car will think that it needs to let air out of the rear to try and get it back to normal height. So you'll end up with a car that when you're driving down the road is just slammed at the back, just fully aired out at the back. If that's the case, suspect this. Suspect that that bottom bit is broken. Now, there is another way that you can have the rear of an LS air out and be problematic, and that's caused by this rear solenoid. So if we look at these two solenoids back to back, you'll see the condition of them is completely different. This one's in pretty decent condition, you know, it's still got its galvanized coating on it, whereas this one is just rusted away to nothing. And that's because the front one is hidden up in the wheel well and it's protected from the elements, whereas the rear one sits just behind the rear differential and is fully exposed to weather and road debris. So when these get rusty, they start to leak around this point here. And when they start to leak, that will usually present itself first as a car that has perfect ride height when it's driving along. But if you leave the car sitting for a day or two, you'll notice that it starts to lose height at the back, and it eventually will just lose all of the air out of the rear of it. That's usually caused by a slow leak from this due to corrosion. So if you've got a slow leak that kind of happens while the car's not running, but seems to be fine when the car's running, get under your car, get some soapy water, spray it all over this and see if you can find anywhere where it's bubbling or leaking. They are known to fail, the rear solenoids. Front solenoids, not so much of a problem. And finally we've got the compressor. Compressors do fail, it's not unheard of, but it's also not all that common. They're a pretty reliable unit. The most common problem with these is noise, that them getting noisy and making clacking noises and knocking noises while they're running. 9 times out of 10, that's these bushings. There's 1, 2, 3 of them there, and they just get worn out over time and perished, and when they do, like that one has, this will start to knock as it's running, and they'll start to jiggle around and just cause knocking noises. If you can hear your air suspension compressor running while you're inside the vehicle, that's not normal. Your bushings need to be replaced probably. There are instances where people have had these be noisy and replacing the bushings hasn't fixed it, but they're in the minority. It's usually the bushings. I'll put the part number for these in the description. They're quite inexpensive from Toyota. If you remove your front wheel, you remove the wheel arch liner, you can get in and change these without having to rip the whole front of the car apart. It takes about an hour. It's not too hard to do. Well worth doing if you can hear your suspension compressor running while you're inside the vehicle. And that basically covers it. So the most common failure points again are struts themselves wearing out, the height sensors either getting water ingress or getting bent or broken, the rear solenoid valve starting to leak, and these bushings wearing out. So if you need to find a problem that's happening with yours and you need to fix it, those were the areas that I'd say you should look at first. I hope this was useful to everyone. If you've got any questions, any comments, leave a comment below and I'll get back to you. Thank you very much.